In this video, I'm going to help you take tools that you might already be familiar with working in Excel and transfer that over to working with R in RStudio. So what we have before us here is a data set that is for a mountain bike wholesale company, and this is their sales over a period of years. So let me walk through some of this data so you can understand it before we start getting into working with Excel and then transferring that over. So if we look all the way at the end of the data frame or data set here, we have the customers. So it's a wholesale company. So these are retail companies that buy from the wholesale company. And for example, this customer, the name of the company is Airport Bikes. They bought an air pump through the warehouse in 2008, January 5th, and they bought one of those air pumps. So this sales quantity is the number of units. We won't deal with this. The revenue is the total price paid on that transaction. So notice it's higher here when they bought 2 of those units. So it's twice the amount here. So this is the total revenue for the transaction or before discounts. Then this tells you what currency it's in, and then the discount is the amount discount from the total revenue price. Net sales is the price that was paid in the end. So here the Airport Bikes bought 2 air pumps. They paid $43.30. The discount was $1.30, so what they actually paid after the discount was $42. The company, the wholesale company has different divisions, so you can see those, and it has different sales organizations. So the organizations are Germany South, Germany North, and then US East and US West. And then, of course, the country that the organization is in. So this is our data set that we're going to work with. There are many functions that you might use in Excel. I'm going to go through some of the most common, and then I'm going to walk through how to do that in RStudio. So this is what RStudio looks like, and RStudio is just a way to work in R, and it gives you some visual feedback and options that you wouldn't use in base R, where you would just use a script to interact with it. But if you open base R, it looks pretty similar. So if instead you just open this R program, it's pretty similar. You have this console that you're going to put things in. You can open a new script that you're going to put the script in there. You can see different windows, so it's pretty similar, but it doesn't have all the functions that RStudio has. Okay, so the first thing we need to do is get the data into R. So what we have here in the spreadsheet format in Excel, we want something like that in R. In R, this is called a data frame. So a data frame is like R's spreadsheet version. So we need to import the data frame into here. You'll see here I have a link to the data, so that will be provided in class, and I will provide it on the YouTube video so that you can get the data to work with. First we will import, and then we'll come back to this up here. So how to import it, I have it already, the script written here, so every time I use it now, I can just highlight that part and run it, and it will import the data frame here, or to import the spreadsheet as a data frame here. So if I open this, I can click on it, and notice now it looks like the spreadsheet that we saw in Excel. So this will be what we're working with. It's the equivalent of the spreadsheet. But how did I do this? Well, the easiest way to get started with it is do File, Import Data Set, and if it's a CSV file, that's from one of these text ones. If it's an Excel file, you do it from Excel. So let's say I go to this CSV file, I navigate to where my file is located, and that's this GBI data CSV. So double click on that. Notice what happens is it tells me about the file, and then the data frame here is what it's going to look like when it's imported into R, which looks like a spreadsheet. So I import that. It opens it up for me to look at. And notice it also put the code down here. So the part that I need is this GBI data, create GBI data. This arrow is how you assign something. So the left-hand side of that arrow is the object you're creating. The right-hand side is what you use to create it. So here it's saying read a CSV file that is given by this path, put it into, which is the arrow assigned here, the GBI data object. So I can name this whatever I want. So if I don't remember this part, I can visually do it, then copy and paste and put it up here. So I copy and pasted it and put it here. The reason I might copy and paste it is so that in future versions I know where the data is stored and where it came from, and I don't have to visually click through every time. I can just run something and it can do the same thing every time. If, let's say it was an Excel spreadsheet, which is what I'm looking at here, this is Excel, well, you could do the same thing, go here to File, Import Data Set from Excel. So, and there are some other options here as well. So if it's a TXT file, you could use this, Excel file or something else, one of these other ones. Then that's what is down here. So if you wanted to do the Excel version, you click on those, find it, and then it would put this in the console. This is what would come out of that. Something to notice here in the console is it has these arrows, well, or whatever you want to call them, these arrows tell it that it worked and it ran in the console. So it also is a way to say if there's an empty arrow there, it's ready to go now. So if it's not there, it's still running something. Well, those don't go into your script because you're not running arrow and this stuff. You're just running what comes after it. So you just want to copy the text after that. Then I also have these pound signs or number signs or hashtags, whatever you want to call them. These are how you comment in R. So I've commented these out so that when I run this code again or this script again, these aren't going to run. So, you know, if I have anything in here, I want to make a note to myself or I want to save something in there, I can just make a comment in here. Another thing I have here is remove. So if I want to remove something, I can RM and then in parentheses is remove. So I could remove this and it'll go away. So I could do the same thing here. I'll just put it in the console this time. And what I have up there is GBI data. I enter, and now notice it removed it from there. So let's get it back. Then a couple of things to notice here. So notice here it says library. It had to read in a package to be able to do this read Excel function. So how R works is it has base functions that are available in any version of R or any instance of R, but then people write packages that can add to the functionality that is available in base R. And so often we need these packages. We're going to use a package called tidyverse that is going to incorporate a bunch of the things that are most typical. There is a website that you can go look at. This is this tidyverse package that explains things. So this will tell you about these different packages. There are these packages in the tidyverse set of packages, so it's a collection of packages. So the one we're going to work on today is this dplyr package. So if you go on here, this explains the package and it also gives you other information. So if you go down, tells you how to install it, gives you examples down here of how to use it. And then, of course, this cheat sheet that is always helpful, that helps you remember things about the package. So this is the information here. Also, there is in the course, there's a free online book that gives you some of that information, or you can purchase the paper version. But there are a few resources to get up to speed or answer other questions from using these packages. Okay, so we're going to install the tidyverse package. The first time you use a package, you need to install it. So you would run this, install this here. So I run it. This tells me basically I already installed it, but I'll do it anyway. So I'm going to click no. And you can see it tells me some things. It needs our tools installed. Okay, this is all fine. So, okay, this is already in use, so it's not installed. But if you did this thing, you would have some other text down here in the console come up. Hopefully in the end it says it's been installed. Once you've installed it, you never have to install it again unless you update your R version. But every R instance, every time you open R again, you need to tell it that you're going to use these packages. So here I'm going to use library. Library is the function that says use tidyverse in this instance of using R. So I run that. When you first run a library function with that package, it may give you some feedback there that it's fine. It's not really critical to what we're using right now. We can talk about it later, or if you have questions about it. But you'll run that as long as it gives you nothing, or it says, something positive. Yes, it's there. As long as it doesn't say some error, then you're fine. So this is going to allow us to have the dplyr or dplyr package that we're going to use for transferring our knowledge of Excel functions over to R. So now we're down here. We're going to do some data manipulation. Let me just give you a quick overview of this, and then we'll start doing the comparisons between Excel and R. This is the textbook, online textbook you can go to, and the chapter we're primarily working from is chapter 4, which is going to explain this package dplyr that has functions available for us. Below here, I've given you the main functions that most often are used. There are a few others that can be useful as well, but these are the functions that are available when you use the dplyr package. Notice these are in comments, so I'm not intending this to be used. It's just giving you sort of a recipe book of things you can use, and I've tried to describe quickly what each of those things do. Let me just go over a little bit of this blueprint. So when you create something in R, you need to name the object. So this is the object we're going to name. So just like we imported this data frame over here, this GBI_data, that would be the new object. This is the assigning operator. So take whatever's on the right of this and put it into what's on the left. And here we're going to take an old data frame, create a new data frame. This set of characters here, or the set of whatever these things are, percent greater than percent, that is called a pipe function. That pipe function says, run this line here, then now wait for another command. So this says there's more commands coming after this line. That's basically what it says. So create a new data set from an old data set, and now wait for another command. Notice at the end of this, there is no pipe function. That is to say, we've finished commands, go ahead and run this. Here we have select. So these are all the different functions. We can select, filter, arrange, mutate, distinct. We can group, summarize, and then ungroup, and we've already seen select. So what each of these does is something to the spreadsheet that we're working with, or the data frame we're working with. Select is to choose certain columns to include in the data. Here, the column names are just included. So over here, where it says product is a column name, so the names are at the top of the column. We could include product as a column to hold on to. Down here I have select with a negative sign in front of it. That's to remove a column. Filter is to keep only rows that meet the conditions in here. So I'm giving you some hypothetical conditions. One is that the row in that column has a value greater than 0, or it's not missing. Is.na is missing. I probably should do is not missing. Not is.na is not missing. So our exclamation point means not. And the last one is column 3 is equal to yes. When you're trying to test a logical question about is something equal to, in R you need to use 2 equal signs, so is equal to. Otherwise it will try and assign something to it rather than test whether it is equal to. Okay, so that's this would be an example of something we could do filter with. Arrange is sorting, and I can sort ascending, which is this, or descending, which is a negative value. Sometimes we need to do something else, but that works a lot of the time. Mutate is creating a new column, so notice I have a new column that I'm creating. I'm setting that equal to some calculation over here. Distinct is keeping only non-duplicate rows. Group by is performing functions by group within the data. Summarize is creating a summary, and that would also be done by whatever group is there. Ungrouping is necessary because once you group a data frame, it holds on to that in any future calculations. So if you're meaning to do a calculation for the entire data frame, but it's grouped already, it'll create grouped output. So anytime I'm going to do some sort of functions with grouping, I ungroup afterwards just to make sure I don't forget that it's grouped later. And so this is a set of functions that you'll commonly use. Okay, so that was just an overview. Don't necessarily need to know how to use it yet. We're going to do that now. So let's go to Excel and let's start doing some things. First we're going to do is create a new column. So let's say that I want to create a new column that captures what the price for every unit of a product is. So here I have the air pump. I have one product that was sold. It was $21.65. Here I have a product, the same product, but 2 of them were sold, and it's $43.30. What we don't have in here is the price for every unit. Of course, if we look where there was 1, we could see what it is, but we want to know for every product what the price per unit is. So we can create a new column. And create that calculation. So in this cell, type equals, creating a price per unit would be taking the total revenue divided by the number of units sold. So in the first one, when there was only 1 unit, that is the price per unit. But in the next one, if we do the calculation, 43 divided by 2 gives us the same price per unit. Okay, so this gives us we just calculated a new value. Well, to apply this to the entire column, right, if we want to have price per unit for every row, we have to take this formula and drag it down, right? Well, we have 30-something thousand rows, so that's going to get annoying dragging it down. We could copy and paste it, which is what I'm going to do here, but doing things by cells and expanding those cells is a little tedious in R. So I'm just going to jump down to the bottom here and then jump back up, and I paste it in here. Okay. So now I've got a new column, which is the price per unit. Well, to do that same thing in R, I'm going to take the old data frame, move that into a new data frame object. I'm going to call that DTA, so I'm reading DTA as data. And continue on once you've created that new data frame. Wait for a new function And mutate is the one that creates a new column. So we name the new column, price per unit. We set that equal to whatever comes after that. And here we name the column that we're going to do this in. So in here, the revenue column is called revenue. So we're going to divide by this column, revenue. Divide the revenue column by the sales quantity column. So revenue divided by sales quantity. You can use a lot of different algebraic functions here, or whatever they're called here. So multiply, divide, subtract. You can do exponents, natural or logs of different kinds, anything like that. So that's going to create a new column. Notice I have to run this as a unit because this says go on to the next row. So notice if I run just this line, so I highlight it, click run, has a plus down here. That means it's waiting for another command, and that's because of the pipe function. So if I now run the next one, it will make it work. Okay, so now we have this new data frame over here, DTA, or instead of running one at a time, you can just run it, and now it does it all together. So if we look at DTA, look at the end, we have a new column that is the price per unit. So anytime you're dealing with columns and creating new columns, mutate is the way to do it. Next, we're going to sort, and we want to look at a customer and every day of their transactions. So let's go back over here. So the first part we have to do when we're working with the Excel data is we need to highlight the parts we want to sort. So this is our data. Of course, in each software, there are lots of ways to do things. I'm just going to go through the most common. And then we can go to data, sort, and let's go by customer. We need to add another one, year, month, day. Okay. So now it's sorted how we asked it to be, and we can see Airport Bikes made a purchase of a men's off-road bike, one of those bikes, on January 3rd. On January 5th, it made 2 product purchases, which was 1 air pump and 2 water bottle cages, so, etc. We could keep going down here. To do that same thing in R, that sorting is a range. So what I'm going to do is take the DTA, the data frame we already created, and I'm going to create a new data frame with that. Well, if you name them the same thing, it's just going to override it. So it's going to take the data we already created, sort it, and put that as the same name. So if we run that, so a range means sort. Notice I have customer, and then to separate things I have a comma. So customer, comma, year, comma, month. Run that, open it, notice it looks the same now. So we have, for each customer, we have on January 3rd, we have a men's off-road bike. So the same setup as we do in Excel. Okay, next we want to filter. And so let's go back to, and I'm going to filter for the product with just the professional touring bike silver and the year 2010. So how do we filter here? Same thing. Select the data that we're going to work with. And click on filter. Then I wanted the product. You can use these arrows to find or select, filter for which objects you want. So I'm doing the professional touring bike silver, click on that. Now that's the only product we have in here. And if I want to do years, now 2010 is the only year. One of the good and bad things about this in Excel is notice this has just left us to see the individual lines or the rows where this criteria is met. In R, it doesn't. You don't filter and then go back to the same data frame as you would in this case. So once you filter, that part of the data is gone. So let me show you how to do that. So here I'm going to create a new data frame, so that way the old data frame that I have is still there, and the new data frame that I'm creating is going to be there. If you overrode it, so if you had DTA, taking DTA, creating a new one called DTA, well then once you filter you would lose all of the other rows. So here I'm filtering to keep these rows. So filter doesn't mean filter out, get rid of something. Filter means keep these things. So filter, I'm going to take a product. Remember, it has to have two equal signs, is equal to, then this professional touring bike silver, and year is equal to 2010. Once I run this, I have this temp data frame. Notice it only has 633 observations or rows, whereas before it had 36, almost 37,000 rows. And to double check, we can click on here and do this. So the advantage in terms of doing this in Excel is that you can visually select what these things are, right? You can use a drop-down menu to select things. The disadvantage is you have to manually do this and click through things. The advantage in R is it can be repeated over and over. So I'm going to do this later, then I can work with this temp data frame and do new things to what I'm working with. And let's say you needed to do this every year, you don't have to click through and do it every year. Okay, next one, we're going to create a summary of a column. So let's go do that. So one of the ways to do that, let's say we wanted a summary of the revenue here. And here in R, I'm doing summary of revenue and the discounted revenue, so net sales. So let's just do revenue. So I'm going to go to the bottom here. And let's say I want to do the total. So sum, and I'm going to select the whole column, enter. So what I have to do first is remove the filtering. So data, I had filtering on before, and now I remove filtering. Then I can go ahead and do this sum. So I do equals sum and select all of these. Every row in this column, I get 121 million. Over here, I get 117 million. So the total cash collected from customers for this company during this period is 117 million approximately. All right, so let's do this in R. Here, we're going to take a data frame, create a new one, temp, and notice I'm overwriting the temp that I created before. So if I wanted to make sure I kept all of these, then I might name this something else. But right now I'm just going to overwrite that. So summarize is the way to create a summary. And in the summary you have to name the columns too. So I'm going to summarize. I'm going to create a new column that is called total gross sales and total net sales. The function I'm using is sum. Of course, there are other functions. So in Excel, there are ones like average, min, and max. In R, most of those transfer over. Instead of average, you would use the function mean, but min and max and other things will work here as well. So we're going to create the sum, and it's not grouped, so it's just going to create the sum of the whole data frame. And I go over to temp. Notice it gives me the total gross sales and the total net sales. Now let's say we want to do a summary by group. So let's go over to here again, get rid of this. And so let's highlight the whole thing. And now we need to sort it by product. Now this will work a lot easier, so let's subtotal in each change in product. We're going to sum, and we're just going to do net sales and revenue. Okay, there we go. So now it worked really quickly. That's because it didn't have to go through so many products. Click on 2 here, it collapses it, and now we have the subtotal the sum for each of these products. Notice at the bottom, the grand total, those are the same as what we had before when we summed up the amounts. Okay, so how do we do this in R? Create a new data frame from the old data frame, group by product. So notice the group by function here is going to say whatever we do for each product separately. And summarize is the summary function. And I'm going to calculate a new column, which is total gross sales, set that equal to what we're going to add up here. So sum of revenue and sum of net sales. Run this, the new data frame temp. Notice it shows the same thing. So the air pump total, it gives each of those. The difference is that we don't have an automatic total, which we would use back up here. Okay, next one, keeping unique observations. So if you have duplicates in your data, what can you do? So let's first remove all of these subtotals. And let's say we only want a list of unique customers in here. So we can collect the data, or select the data, and go to remove duplicates. And let's say we just want the list of unique customers. Click on OK. And notice it just gives us one of each customer. We don't want to leave that, but sometimes we want that. So how we do this in R, new data frame, distinct is the function for keep non-duplicates. Look over here. There we have just the list of unique customers. All right, so then let's go through just a few of the other summary functions we might use. Notice here I had group by, and so if I was using that temp data again, it would run stuff by how it was grouped. But now I'm starting with a data set that isn't grouped already. I guess let me show you how that works. So if I do I run this by product. Whoops, it says it is not in there. That's because I forgot to mention R is case sensitive, so you have to make sure it's the right case. So now it's grouped. You won't see anything in the data frame. You open it, you don't notice anything that it's grouped, but it's keeping track of it. So I'll show you this and then we can go back and explain this. But if I run this, now notice it has each product. It's done things by product. So if I now ungroup, now it's not going to leave it grouped. So when I run this part, notice it's one observation. It's for the whole data set. Okay. So here, this is just a list of possible summary functions. There are others too. So we already did sum. Mean is another one. Standard deviation, minimum, maximum. Quantile is a percentile. So 0.5 is the median. 0.75 would be the 75th percentile. Notice in all of these I have this comma na.rm equals true. The reason you use that is if there are missing values in there. So missing values are usually labeled as NA. Well, if there are missing values in there, it says remove them. RM is removed. So na.rm means remove the missing values before you do this summary calculation. So then this will allow you to calculate a mean if there are missing values in there. Otherwise, it'll just return a missing value if you have missing values. So that's a sort of a technicality that at some point you might encounter. So we run these and you end up with some summaries of each of these things from revenue. Let's try a couple of other things, some window functions. And this first what we're going to do is we're going to get by customer. So this is what I mean, you can create a data frame and then work from it. So I'm going to, for each customer year, sum up the total net sales, the total amount that we got as the company from that customer. So we run this, and it tells you, oh, it's grouped this way, which is what we wanted. So notice we have then for each year, airport bikes in 2008 had this 85 million, or we got 852,000 from airport bikes in 2008, more in 2009, a little less in 2010, and a little more in 2011. Okay, so this gives us by year for each customer. Well, let's say now you want to, for each year, you want to know what was the prior year's information. Okay, so what I'm going to do here, I have this data frame that I can work from in this temp file. So I want to do the same sort of thing in Excel, but it starts to get more complicated. So if I want to group by product and year, so product and year, then we have to get into other tools like pivot tables, or something like that. I don't want to now teach you Excel stuff, so let me just do a shortcut here. So we would like to be able to do the same thing in Excel. Here's what I'm going to do. We're going to go back here, and this is not a, you can't go in here and click and find a visual way to do this, but I'm going to do a write.csv, so that's going to write a new file, and I'm going to write the temp object that I just had, which is over here, and I'm going to use the same file path that I just used, or that I read the file in from. And I'm just going to rename it here. So if I do, let's say, okay. So I'm going to write this to a new CSV file. And now I'm just going to open that up. And then we'll have the same thing available. Okay, so this is what came out of that write CSV. There are other options to get rid of this row number thing. And so if I want to use this, what I want to be able to do is go back, let's say we're in 2011, and I want to go back and say what was total revenue for airport bikes for the prior year. I'm going to go back and get this here. So we're going to do window functions. These are called leads and lags. That are the first things we're going to do. So a lead would say, take whatever row you're in. So we're in 2009. Lead would be go down to the next row. So how would we do that in Excel? Well, we would say, and maybe I'll create a new column just to look at here, lead and lag. So the lead would be, say, go down to the next row. So this is in 2009. Go down to the following row here. And in 2009, go for the lag would be go up a row. So go up to the prior row. So in terms of, if this is sorted by company and year, or by customer and year, then this gives us the current year's total revenue, this gives us the next year's total revenue, this gives us the past year's total revenue. Why is that useful? Because in R, the only functions that you can do, or most of the common functions, are working across a row. So in Excel, let's say you wanted to calculate sales growth from the prior year, from 2008 to 2009, let's say. So this would be a growth column here, and let me make it a little bit bigger for you. So we could do that by saying, let's just do changes in sales. That would be this year's total revenue minus last year's total revenue. So notice when calculating that, it went from one row to another row. Well, in R, we can't really do that. So we have to create the rows first before we do the calculations. So here we're going to do the same thing. So this is current years, this is last year's. Maybe I should redo what I just did. Okay, so remember this was this year's minus last year's. Well, we can do the same thing once we've done the leads and the lags, so we can do current years minus the last year's. Gives us the same thing. So leads and lags allow us to go cross over rows when we're doing calculations. Well, how do we do this for every observation? Let's just deal with this lag one if we're trying to create sales growth, for example. We can drag this all over the place. Then I'm just going to drag it and show you a few problems. Well, what happens here when we try and go back up a row is it grabbed this row here. So notice it went back up to here. This one worked fine because we went back up to here. This one didn't. Let's look at another one. So I'll just highlight that now. What about this one? Notice this is for Ulster cycling. It went back up to airport bikes prior year. So if we're going to make this correct, what we have to do is every time there's a change in the company or whatever group you're interested in. So this would be the same thing here. This is the first observation for Bavaria bikes. When you go back, then this is a different customer, so that one is no good either. So then what you have to then do in Excel is you would do this, right? Drag it down and keep doing the same thing. But then every time you got to a new observation or a new customer, we'd have to tell it doesn't work, right? So we're gonna have to delete these, whoops. All right, so you'd have to keep doing that every time you ran into a new customer. So that could be really tedious if you're trying to get lags to work. Of course, you could do that even more complicated by doing something where if this cell is equal to the cell above, then do this lag thing, but that starts to get super complicated, and I don't know about you, but that is tedious business for me in Excel. So let's go look at how that is done in R. So notice we had this customer in year. So let's just sort it by customer in year. It already is. Well, if we want to do this for each customer individually, what that is doing here is saying, let's do this only for airport bikes. Then let's do this only for Ulster cycling. So it's doing it sort of one at a time. Well, if you did that for each one, then you would say, go back as long as there's something to go back to. So you would be here, well, there's nothing to go back to, so you can't go back. And you would get here, that would be as far as you go. So it does this cleaning up for us. So as long as it's arranged and then grouped, we can do these leads and lags without any problem. I'll come back to this one in a minute. So create a new column, lag one, create a new column, lead one, and the function is lag, and this tells it how many rows to go up. Lead tells it how many rows to go down. So if you did 2, it would go back 2, in this case years. Let's run this. So it's going to take this and it's going to override it. And what does it look like? So notice for airport bikes, it got rid of the first one. Now for Ulster cycling, it got rid of the first one. NA is missing, so it'll do that all the way down. So it sort of cleans up what's there. For lead, it goes the other way, right? So this is the first one available. Go down one, then this is the lead, right? So this is the next row's information. Well, if you're the last row for airport bikes, there is no next one, so then it leaves that missing. Okay, the last one to talk about is cumulative revenue. So what if you want to add up as you go down? So how would you do this in Well, you would say, you would first say this is the first observation for this. So that's the first one. Then for every other one, you would say it's the past one plus whatever the new one is. Okay, so then you would go through doing this. Again, once you hit a new row, you would have a new problem. So then this would have to be start over and then do it again. This plus this. Oops. Oh. And you'd keep doing that all the way down. You think, oh, well, I could just copy and paste the formula a bunch of times. Well, what if you have customers that are not there, if they're not there in the same number of years every time, like some only have 3 years, others have 5 years, well, then this doesn't, that copy and paste quickly doesn't work. All right, so cumulative sum, there are other ones, cumulative products, cumulative max, cumulative mean, other things like that we can use. So these are window functions. Let me give you one more useful function, and we're going to do something similar here, but we're going to do the product year instead of customer year. So same thing. Now this is my temp data set. So this in 2008 for air pump, 2009 for air pump, same thing. So I'm going to save that to work with in Excel. Use the same thing. But I'm going to call it by product. And the things I want to do here is for each year, I want to get which product was the highest revenue product. So by product. So how might we do this? Well, it's already sorted by product, so that gives us something. But we want to do each year, and then we want to do the highest revenue one. So there are several ways to do this here. Let's just sort it here. So we will do for each year the total revenue, and we're going to go largest to smallest. Okay, so each year we have men's off-road bike. This was the highest valued one, and then it goes down to this is the lowest revenue producing. So let's highlight this for a minute here. And perhaps we want to make it more official, so this is the rank. So we could do, right, something like this that says here is the number 1 producing, here's the number 3 producing, right? That's the sort of the rank of the products. We could also do percentiles. Let's say we wanted to know in the top, it's in the top first percentile, for example. That's a little more complicated, so let's try and figure out a way to do that. That would be, it's confusing. So that would be this number divided by the total. Maybe let's just do the max. Something like this. This is in the top 5%, and so on. Okay, so the top 5% of course, when there's only one, that doesn't make a lot of sense. But these are 2 ways to sort of rank things. Well, we can do the same things here. So mutate. We're going to do this by year. We can rank it. So min rank. The min part just tells it if it's if there are ties, then give it to the lowest value. and we're going to go descending, so that goes from the highest to the lowest. And percent rank, we're going to say what percentile. Well, we want the highest percentile to be the highest, so let's go ahead and look at what that looks like. So now it says in terms of the, oh, I did it in the opposite way, sorry. So if we wanted to do it exactly like I have in the other file, then in R, then we would do something like this. And we would do this divided by this fixed. So depending on how you wanted to say it, this is in the 100th percentile. Of course, I could have subtracted, but, and then this is in the lowest percentile. In here I did the highest revenue is in the 100th, the largest percentile, the 100th percentile. We could reverse that just by putting a negative sign here. So these are ways to rank in our data. Here, notice it's in 2008. This was the highest ranking. In 2009, it was the highest ranking. So every year, the MIN's offered bike is the highest revenue producing product for this company. When we get to the second, notice in 2009, this was the deluxe touring bike, the silver one. In 2008, it was the professional touring bike. So, you know, other than the top one, there's some variation in what is the top one each year. All right, so this gives probably too much to go through and too much information. But hopefully this gives you some basic ideas. If you're going to go do something in Excel, here's the way to then transfer that over to work in R. And you can combine a bunch of these. So we did that at the very end where we had a couple of things combined to create a data set. Of course, it could look like this too. You could use, it may be at some point you use all of these different functions or even other ones that we will talk about in the future. Let's highlight a few things here. So remember, the double equal sign is for logical evaluation. The group by stays with the data frame until you ungroup it if it's the same data frame. The leads and lags, when you're doing leads and lags, you need to sort and then group by whatever your group is, otherwise it will get false next year or the past year's sort of values. So if this was not grouped by customer, you would have the same problem we had in Excel. And then, right, the other things, remember that there's more information here on the Tidyverse website and in the R for Data Science